Hello students and friends, welcome to my YouTube channel. Today I am going to discuss center of gravity problem, composite section center of gravity problem. So how we will solve? The given section is problems I taken. What is there here? One semicircle, one square, one triangle, inside circle is there. So diagrams will be like this. See, this is semicircle. Just 1 minute. Opposite. So what type of diagram is there? This semicircle is there. Then one square is there. One square is there. One triangle is there. And in between one circle is there. So big circle dimension is 30 centimeter. This is 15 centimeter dimensions they given. So section 1, section 2, section 3, and this will take section 4. So 4 sections what we did? We taken out semicircle with dimension 30 centimeter. Then square 30 centimeter, 30 centimeter. You write centimeter because already given, so I not wrote. So this is the centimeter. Okay, this is 15 centimeter. You can write or you can leave it like this. So 4 sections we taken out. And we finded the area. What is area of the section 1? Pi r square by 2, because circle area is pi r square by 2. His radius is 30. So we calculated here pi into 30 square. So we got this answer. Then square, side square. So 30 into 30 we got this. Area of the triangle, half base into height. We got this. Then area of the circle, pi r square. So we got the area. Now what is the next part? Next steps. First steps, you take all the how many section is there, you take out, and any section is the inside that you take out. So that will formula will write the minus. So then we'll find the center of gravity for the entire composite section. So what is center of gravity actually? Entire body weight will act at a particular point in that section is known as center of gravity. So center of gravity, if single sections will take, suppose we are taking rectangle, this is B, this is L. So where will the center of gravity? Center of gravity will be the middle. Center of gravity will be the middle. Then what is this distance? L by 2. What is this distance? Suppose this distance will take na B by 2. So what is center of gravity? X bar, Y bar is equal to nothing but L by 2 comma B by 2. So center of gravity for the rectangle we know directly. Similarly, square also middle point. Triangle we have some rule. Semicircle having some rule. That only I will tell how to get the individual section of center of gravity. That is called x1, x2, x3, x4, and y1, y2, y3, y4 will calculate. Area already calculated. So that way we'll substitute the value and we'll get the answer. So why we need this is, see this final center of gravity, what is the formula? 4 section is there. So a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Then fourth section is circle, is inside. So what we'll do here? Minus a4 x4. Minus a4 x4. Then minus a4. Because this sections having inside, so we have to subtract. So this way we can get the x bar. But what is required here? A1, A2, A3, A4 already you know. X1, X2, X3, X4 need. What is this X1, X2, X3? Individual section of center of gravity. How to calculate that only I will tell the trick. First you see this. Suppose semicircle is there. Either this way or this way, whatever way is there. So what is the center of gravity for the individual section of semicircle? Suppose this is there. Center of gravity will be near here because this is broader area. So center of gravity nothing but middle part of the particular object. What I told? Particular object center of gravity will be the middle point. So approximately middle point to here. So suppose we are seeing from top. That means this distance. From here this distance. So from this distance if you see, this will come 4r by 3 pi. This is the formula. 4r by 3 pi. If you will see from the bottom, it is r minus 4r by 3 pi. If you will see this side, r. If left side, r. That means we'll reach here. From here we'll reach here. This point. from here. So this and this will add now, again finally will be the radius r. So this way we can find the individual section of centrosity, either x1 or y1. Suppose this like this will be there. Similar, if this way you are seeing na r minus 4r by 3 pi. From this side, if you are seeing 4r by 3 pi. 4r by 3 pi. From this side, if you are seeing na r. Again from this side r. That means how will calculate the individual section of center of gravity for semicircle? You see here. Suppose I am calculating here x1. I am calculating little down will write x1. So what is x1 here? We taken the reference axis. That also you see. Before this we know we have 4 coordinates. This both plus, this x minus plus, minus minus, x is plus, y is minus. What we'll do here, given block I will keep in the first coordinate. Given block will keep in the first coordinate. So both will come positive. So will negative value will not consider. So I taken this given composite block in the first coordinate. First coordinate. Then reference axis y and x. From there, from these two reference axis will measure the value. x1, x2, x3 measure from the y-axis, and y1, y2, y3 will measure from the x-axis. Why like this? See here. Suppose this line is known as x. This line is x equal to 0 line. This line is known as y equal to 0 line. Suppose y is equal to 1 line where? Here. So where this distance from measure from where? From the y-axis. Suppose x equal to 1. Measure from where? From the y-axis. That's why x1, x2, x3 will measure from the y-axis, and y1, y2, y3 measure from the x-axis. See, so y equal to 0, y equal to 1. We are measuring from the x-axis. X equal to 0 line, x equal to 1 line, x equal to 2 line. Measuring from where? From the y-axis. That's why x1, x2, x3 will measure from the y-axis, and y1, y2 measure from the horizontal axis. Okay. So this is the trick you have to remember. Now x1, you see here. From here to from semicircle only. Leave it, forget other section. Semicircle from now, what type? This type of there. So what we can write here? R minus 4r by 3 pi. So write in bracket now, it will be looks good. So r minus 4r by 3 pi. R is how much? 30. 30 minus 4 into 30 by 4r by 3 pi. So this value already we calculated. How much is coming? x1 20.45 centimeter. 20.45 centimeter. So x1 over. Now x1 will take from the section 2 rectangle square. So square means half distance. See here, x2 na half distance. What is 30 by 2? Because if you square also there, you see from this side half distance, from this side half distance. Half distance 30 by 2. But from this reference axis, where this is square? After 30 centimeter. So add the 30 centimeter. So how much will come? 15 plus 30, 45 centimeter. Now x3. X3 now this is the right angle triangle. What is the rule for the right angle triangle? See how to know the individual section of center of gravity. Listen here carefully. This is the, suppose this is the B, this is the H. Suppose we are seeing this side, it will come B by 3. From this side you will see na 2B by 3. Now look, from top will see na H, so H by 3. From the bottom you will see, from bottom to top, so 2H by 3. This B by 3 for this side. From left to right we are seeing na B by 3. Lower cross sections 2 by 3. Why like this? Because we know if right angle triangle is there, same center of gravity will be somewhere belongs to be here, broader area. Somewhere will be here. So like this there. From there, this distance is 2B by 3. And this distance will be B by 3. suppose you will forget where b by 3, where b by 2, b by 3, b by 3 na, assume some value. Suppose b is equal to, you take 6. So what will happen here? 2 into 6 by 3, it will come 4. And b by 3, it will come 6 by 2, 2. So this distance is 2, this distance is 4. So that way, suppose by mistakes you are writing here 2b by 3, here b by 3. Substitute one value, some numerical value, now you will get bigger value this side. So that way you can change. So that means, remember, from the lower sections 2b by 3, from the broader sections b by 3, from here, see here, lower sections here, suppose vertically you will see 2h by 3, h by 3. So that way. Now look here, what type of triangle is there here? So we are seeing from this axis, y axis. So this way is there, this way na, b by 3. b by 3, b now how much? 30. This what is this one? This one 30 centimeter. So 30 by 3. But where is this from the reference axis? 30 centimeter. So take the 30 centimeter. So 3, 3, 10. So 40 centimeter. X4. X4 now we are taking from the circle. From this distance to this distance. What is this distance? 30. So directly we can know the 30 centimeter. So this way we know. Now if we will see the y1, y2, y3. If you see here y1, y2, y3, y4. So see here y1. From this way, this circle. What is this distance? R. R now how much? 30 centimeter. Now second one. Half distance. What is this distance? 30. 30 na, 30 by 2. But where is this? This after 30 centimeter. So 30 centimeter. 30 plus 15, 45 centimeter. Now y3. Where is the y3? Semicircle. This. See here, lower sections we are seeing. From the lower sections. What will be the lower section? 2h by 3. This how much? 30. So 2 into 30 by 3. So 20, 10, 20 centimeter. What is y4? y4 is circle. From this point to this point, directly 30 centimeter. So this way we know the x1, x2, x3, y1, y2, y3. So x1 is coming 20.45, x2 is coming 45, x3 is coming 40 centimeter, x4 is coming 30. Similarly, y1 30 centimeter, 30 plus 30 by 2, 45 centimeter. Then 2b by 3, 30 centimeter. If you know the x1, x2, x3, y1, y2, y3, then substitute this value. Substitute this value here. A1 you substitute here. A1 what is? 1, 4. Write different color. What will write here? A1 value already we calculated here. 1413.72 into x1. X1 is 20.45 plus A2 900 into x2 45 plus x3 plus A3 what is 450 into what is x3 40 minus last section A4 is 706.86 divided by total area. Total area how much? 1413.72 plus 900 plus 450 minus 706.86. If you will calculate, you will get x bar here. If you will calculate, you will get x bar here. X bar is coming for us 32.19. X bar is coming here 32.19 centimeter. So this is the A1 x1, A2 x2, A3 x3 plus A4 x4. I not wrote here. X4 is 30. So x4 here by total area. So a1 x1, a2 x2, a3 x3, a4 x4. So this way we can get. Now if we'll do the y bar. Similarly, y bar, what we can write? a1 y1 plus a2 y2 plus a3 y3 minus a4 y4 divided by total area a1 plus a2 plus a3 minus a4. So if you know this all the value, again you substitute here. So a1 y1 how much? 30. a1 is already what is 1413.72 into 30 plus a2 900 into y2 45 plus a3 450 into y3 20, then minus 706.86 into y4 30 divide by total area. Total area, if you'll add, this total area will be same, it's coming 2056.86. 2056.86. This is the total area. This add and subtract, this value is coming. And this way y bar will come. Y bar is coming 34.38. 34.38 centimeter. So x bar, y bar we know. Now you can represent in the, suppose you want to represent this in the diagram. So you can represent this way. So x1 is 32. So from there you have to, that y bar is 34. So this is 30. So it will go little big, little go there. So this is the, you can say y bar. Now this is the x bar line. This is the x bar line. Y bar. This point is nothing but center of gravity for the composite bar. So this way we can know. So only simple trick. Take the all the how many section is there out. Find the area. You know, like the rectangle will be there, square will be there, triangle will be there, quarter circle, circle will be there. More than that will not be there. Then assume the axis of reference. Find the x1, x2, x3, y1, y2, y3, which is individual section of center of gravity. Then substitute in this formula, get the answers. Okay. Okay, students, watch this video and subscribe the channel. Share this video to your friends so they can get the maximum benefit. Okay. Thank you.